Okay, for 4.4 I'm going to take a look at three problems. Going to take a look at, they're all similar, we're going to take a look at evaluating the sine, cosine, and tangent of an angle that's not between 0 and 360. And we're going to do this without a calculator. Going to do the same thing basically for problem number 2. It's just you're going to find the sine, cosine, tangent of an angle in radian measure instead of degrees, but same idea as that first one. And then the third one I'm going to do is finding, they're going to tell you that the cotangent of theta is equal to -3 or something. They'll tell you it's in the second quadrant, and then they'll ask you to find some other random trig function. So similar type problems today. Alright, so for the first one, find the sine, cosine, tangent. Doesn't matter what the trig function is. When they give you an angle, you want it to be between 0 and 360 if you can. So the idea would be take whatever angle they give you and either add or subtract 360 until you get it in between 0 and 360. It'll make it a lot easier if you do that. So if you subtract 360 from 750, you're going to end up with 390. Of course, that's still not between 0 and 360, so I'm going to subtract 360 again. And I know that realistically, 30 degrees, 750 degrees, those are coterminal, if you remember that word, meaning they're the same spot on the unit circle. So if I look at my little unit circle, I know over here at 30 degrees, my point is the square root of 3 over 2, 1/2. And now I can just answer the questions. It wants me to find the sine, cosine, and tangent. Well, the sine, or let's do the abbreviation, the sine of 750, which is the same thing as 30, is going to be the y value. It's 1/2. The cosine of 750, because we're on the unit circle, is just the x value. It's the square root of 3 over 2. And then the tangent of 750, if I took the y divided by x, remember you can disregard the 2's because they'll just cancel out when you do the the multiplying by the reciprocal. It's 1 divided by the square root of 3, so make sure you rationalize, and I get square root of 3 over 3. So again, idea, take whatever this number is. If it's negative, you want to add 360 over and over and over again. If it's positive, you want to subtract 360 over and over and over again until you get it something between 0 and 360 and you're a little more comfortable, or something you recognize. In problem number 2, exactly the same, only this time they give it to you as a radian. So it'd be the same idea. I would like to subtract 2 pi over and over and over again until I get something between 0 and 2 pi. Or you might remember that if you had a very large number, like say 410 over 3, and you don't want to sit and subtract 2 pi over and over and over again, you could change it to a mixed number. So ignoring the pi, I know that this is really 3 1/3. And I'm just going to put the pi on the 1 here. So I could say it's really 3 and then 1 pi over 3. And if you remember how I did that, I said, okay, the 3, being that it's odd as I count my way around, it's positive angle, so I'm going this way around. Starting here, all my odd numbers would eventually end up here. So that takes care of the 3. I still have to move 1 pi over 3 from here, and so 1 pi over 3 would put me right there. So I know which quadrant it's in. The fact that I see 3 in the denominator instantly tells me it's a reference angle of 60. And since it's a reference angle of 60, I know I'm dealing with the point 1/2 square root of 3 over 2. The only thing I don't know about just looking at that is which quadrant it's in. And now by doing this, I figured it out. Said if you want to take 10 pi over 3 and you prefer to just subtract 2 pi, make sure you get a common denominator, you would end up with 4 pi over 3. And that is a number that I'm familiar with on the unit circle. There's 3 pi over 3, there's 4 pi over 3. However you do it, it would be fine. The only reason I might suggest knowing this, changing it from an improper fraction to a mixed number, is in case that's a very large number. It would take you too long to sit and subtract 2 pi over and over and over and over and over again. Alright, so the big point is, I've now got the point. I see that I'm in the third quadrant, so both of these numbers are actually negative. So at 10 pi over 3, I'm dealing with negative 1/2, negative square root of 3 over 2. And now listing out my information, the sine of 10 pi over 3, again that's the y value since I'm on the unit circle, is going to be negative square root of 3 over 2. The cosine, since it's on the unit circle, it's just the x value, it's negative 1/2. And then the tangent of 10 pi over 3, I'm dividing two negatives, so it's going to be positive. Again, I can disregard the 2's. It's going to be the square root of 3 over 1, or just the square root of 3. So realistically, both of those problems boil down to, can you figure out which angle on the unit circle it is? And then once you have that, do you know how to work with the reference angles and so on? Alright, so problem number 3. This one's not right off of the unit circle. Or at least it is, but it's not numbers that we're familiar with on the unit circle. Alright, so the cotangent of theta is equal to -3. If that's the only thing I look at when I draw myself my triangle, cotangent is negative in the second and the fourth quadrant. So realistically, just looking at this, it's in one of these two quadrants. I'm looking at one of these two triangles. Obviously, it tells me specifically it wants the one in the second quadrant, so this is the triangle I should be drawing. So when you draw your triangle, make sure that it looks just like this triangle, as if it were actually in the second quadrant. Here's my angle theta that I'm looking at. I'm going to go ahead and label it now. I know cotangent is x divided by y, or it's adjacent over opposite if you want to think of it that way. So it's -3 over 1, if I think of that as a fraction. And all I have to do is run through my Pythagorean theorem. It's -3 squared, or 9, plus 1 squared, or 1, is going to give me the square root of 10. And then once I have that triangle filled out, I can figure out whatever trig function you want. They happen to want the sine, so the sine of theta, or this particular triangle, is going to equal opposite over hypotenuse, 1 over the square root of 10, or make sure that you rationalize 2, square root of 10 over 10. Alright, hopefully that'll help you out with your homework in 4.4.